Hello there, it's Jason Gorman here, confined to base, as I believe many of us are during this outbreak. And this is the sixth and final video in our series on test-driven development for C#. If you've missed the rest of the series, I strongly recommend you go back and take a look at the previous videos first. There'll be a link in the description below. Now, in the last two videos, a two-parter, we looked at the differences between inside-out test-driven development and outside-in test-driven development. So with inside-out, basically, we test drive pieces of the jigsaw, if you like, and then we put the jigsaw together at the end. And outside-in, basically, we start by test driving the whole design from the outside through some external interface. And we looked at the pros and cons of both approaches. With inside-out TDD, you end up with tests that are very, very good at pinpointing the sources of failures. So you tend to spend a lot less time in the debugger. But your test code then becomes tightly coupled to details of the internal design. And there's also the risk that when we test drive the pieces of the jigsaw, when we try to put them together at the end, they don't actually fit and we haven't actually satisfied our customer's requirement. With the outside-in approach, there's far lower risk of the pieces not fitting because we actually start by, to carry on with the jigsaw analogy, we paint our picture and then we cut it up into pieces that are guaranteed to fit. Through the process of refactoring, we break our solution down into individual methods and classes, and the design emerges, the internal design emerges. And also that internal design is hidden from the test. It's very well encapsulated. So our test code is much more loosely coupled to the internal implementation, which makes it much easier to change that implementation for whatever reason going forward. The downside of the outside-in approach is as our code grows and our call stack gets deeper, we can end up in a situation where when our tests are failing, it's much harder to figure out, much harder to pinpoint exactly where it's gone wrong. So they produce internal designs that are much more likely to do what the end customer wants. They're much more, they produce test code that is much more loosely coupled from the implementation. But the downside is you're probably going to end up spending more time in the debugger as your code grows. So in the real world, which one do we do? Do we do it inside out or do we do it outside in? Now, this final video, we're going to talk about how we can, to some extent, have our cake and eat it here. How can we work from the outside in, producing pieces that are guaranteed to fit, writing tests that are loosely coupled to the internal implementation, but that also are better at pinpointing the sources of errors, so we spend less time debugging. And to talk about that, we're going to be talking about something called test doubles. A test double is an object that is used in a test. It's not the object that we're testing, but an object that is used by the object that we're testing, that for a variety of reasons, possible reasons, is not the real thing. For example, we may be writing a test for an object that needs to get data from some external source, like a database or a web service, and we don't want to have a unit test that's actually connecting to the web service because that's going to make the test code very complex and the tests are going to run very slow. We want our tests to run fast so we can run all of our tests very quickly as many times as we need to. The time it takes for your test to execute is a big component in your build times, and your build times are can become a big bottleneck in your development process. So it's important that our tests run fast, and the key to fast running tests is to exclude external dependencies. So how do we write a test that would rely on external data without actually connecting to that external source? We can use a test double called a stub. A stub is an object that from the outside looks like the real thing. It has the same interface as the real thing, but its implementation is hard-coded specifically to provide test data. So stubs provide test data. And so what I'm going to do is I'm going to illustrate how we can work on a requirement from the outside in, as we were doing in the previous video, that would involve an external data dependency. And then we'll talk a little bit about how we can have our cake and eat it by taking this approach using stubs. So the example I'm using is a video library, and members can donate movies to the library. So if you've got a spare DVD at home that you don't need anymore, to allow other members of the library to watch that DVD, you can donate your copy. Now, the way that we've envisaged, the way that our customers have asked us to build this, is when we add movies to the library, rather than having to enter all that tedious information about the title and the year and all that kind of thing, is just look up the IMDb ID of that movie, and our system will automatically fetch that information from IMDb using the IMDb API. So we want to test that our movie is added to the library using that information that is fetched from IMDb. But for our unit test, when we're test driving our internal design, we don't actually want to connect to the IMDb API. So what we're going to do is we're going to do it using a stub, and I will show you how. So this is our end unit test here, and we're going to start by writing, so just a normal test, write our assertion first, and our assertion is that our library contains our movie, and we will search for that using the title of the movie and the year. So that's the information we need to fetch from IMDb. Okay, let's create these bits of test data here. So our title, which is just a string, and there's a good movie for you, The Abyss, and our year, working backwards from the assertion, we can just make that an int. That's pretty straightforward. So 1989, I believe. Okay, and now we create our library. Now library is the class that we're testing. So library is real. Let's declare that as its own class there. Okay, and let's give it a method for checking whether it contains a movie. Let's be straightforward here. It's either true or false. Okay. And okay. We'll need an instance of that. So far, so good. And what we're doing is we're donating to the library now. I could at this point look up the IMDb ID of the Abyss, and that would make this test look more realistic. But the reality is, this isn't real data, and this isn't really connecting to IMDb. So it's all make-believe, so I can just make up data. It doesn't really matter as long as the data is of the right type. So a fake IMDb ID, because we're not actually going to be looking it up, our stub is just going to return whatever test data we tell it to return. Let's create that donate method there. And that's our IMDb ID. Okay, now, so far so good. So we've got a library. We're donating The Abyss to the library with the IMDb ID TT0000. And what it should do, if it's working correctly, is look up that movie on IMDb and then fetch the information back as a movie object, probably as a data object. But how is it going to get that information? It's not information that belongs to us, so we can't just pass it in. What we need is an object that can fetch that information. So I'm going to imagine that this object exists. Let's call it info. And this is going to be our library's source of information. Let's call that. And we can define this just as an interface. It doesn't need to be a real thing. Now, let's declare this interface. So we're defining an abstraction here for fetching information about movies from IMDb. Now, how do we implement this? Well, let's use a stub. So this is going to be a stub for movie info. And the stub is going to remember the title and the year that we defined in our test. It remembers the test data. And on command, it's going to return that data when the library asks for it. Let's create our stub there. Okay, so far so good. And now we need to just change the constructor here of library to accept the movie info. So library, you will notice, doesn't know about the stub. It doesn't know about the implementation. It just knows about this interface, iMovie info. So it's binding to that abstraction. So this is dependency injection. Dependency injection allows me to inject in a different implementation of an object. Let's say, for example, a different implementation of movie info, so that we can either have the stub version or the real version. And library doesn't need to know, doesn't need to be changed. Okay, so that's our test. Let's run that and see what happens. Well, we know what's going to happen because contained is currently returning false. And any second now, there we go. So yeah, it's returning false, but we're expecting true. Now, we can make this pass. I'm going to do it the obvious way. So what I'm actually going to do is I'm going to implement library here. Let's assign this to a field. Okay. And then in the donate method, what we're going to do, let's imagine we have a catalog that we keep all our titles in. And that's going to be a list of movies. Yeah. So that's going to be a list, yeah, of a movie. So we're working backwards here. Quite a lot going on. Let's create a class for movie there. And that's going to need to be public. See why later. Okay, now let's add. So our movie is going to come from this data source. So let's imagine we have. Let's call it get movie. A bit more descriptive, and that uses the IMDb ID. Let's declare that on our interface there. Okay. So hopefully it's all taking shape now. So we add that to the catalog, and then all we need to do here is ask if our movie exists in the catalog. So we're using the title and the year. And it should be fairly easy. We need to make our stub do stuff now. Okay. So you need to return a new movie, and that's going to get the title and the year. Okay. Let's create a constructor for movie. And all we need to do let's make these properties. Okay. Which means now these should exist. Oh, we should, silly Jason. There we go. So rather a lot there. In a non-demonstration, I would have probably taken a few steps to get here. But just to demonstrate the purpose of a stub, and our object reference is not set. Is that because? Why is that? Let's take a look at our stub. That should be working. No, that should be working. What object references? Where's our null reference? Silly Jason. There you go. It's a good job we write tests, isn't it? Now it should be working. Okay, thank you very much. So that is a stub. We've used a stub to pretend to be the source of the movie information, to pretend to be IMDb. And then we've programmed it in our test. Notice that the implementation of my stub is an inner class inside the test code. This is test code. It's part of the setup of the test here. So we're specifying in the test, use this title, use this year, so that we can test whether a movie with that title and year is added to the catalogue. Simple as that. Now in doing this, this allows us to unit test the logic of the library without connecting to an external service, so our test runs nice and fast. But we've also created a sort of a flex point in the design here, where let's take a look at our library. Because it only knows about this interface, if we wanted to replace the source of the information, let's say, for example, we don't want to use IMDb anymore, we want to use information from Rotten Tomatoes or some other source, or Wikipedia, then we can do that without having to rewrite any of the library code. So we've created a clean separation of concerns between library and sources of movie information. We've made getting movie information somebody else's problem. And doing that is the key to test driving a design from the outside in such a way that we don't have to write all of the code and then refactor it into the pieces. We can create placeholders for some of those pieces. We can fake it until we make it. For example, we don't yet have an implementation that actually connects to IMDb. We haven't written that code yet. But for this part of the design, that doesn't matter. So I can work from the outside, from the interface of library, and create a placeholder for iMovie info, define what that piece of the jigsaw, what the shape of it must be, so that then we go to implement that in a test-driven way. That piece is guaranteed to fit inside library. That collaboration will still work. And this is a very, very powerful technique for driving more complex designs that are going to be made up of different chunks that do non-trivial things. Now, what our library does is pretty trivial, it's pretty straightforward. In the real world, our designs will be made up of these sort of, not at the class level or the function level, but a kind of a slightly larger, more granular level of organization. We're going to have clusters of classes that do certain jobs. For example, I fully expect that we may end up with more than one class and several methods involved in fetching information from IMDb, deserializing the JSON from that, instantiating the object from that, and so on and so forth. So we may end up with a little cluster of classes, but that cluster will be hidden behind this nice simple interface, iMovie info. And we have designed that interface from the outside, which is the best way to design interfaces, to design them from the perspective of the client. What methods do they need? We've designed that interface, we've defined the shape, the placeholder if you like, into which that piece of the jigsaw must eventually fit. Then when we've got library working to our satisfaction, we can move further into the system from the outside in, move further in and start writing unit tests, test driver design for a cluster of classes, that one of which will implement this iMovie interface. So there's a kind of a bit of one and a bit of the other going on here. There's a little bit of the inside-out approach that we saw earlier, in the sense that we are thinking about, well, there are this other piece here that we need to interact with, but we haven't created it yet. So we're thinking a little bit as we're writing these tests about the end-to-end design. What are the different components or services or interfaces involved? But there's also going to be a certain amount of refactoring and discovery of design within each of those chunks of code, if you like. There's going to be some refactoring going on as well. So it's a little bit similar to inside out. The only difference is we are driving it directly from the outside. So we're always coming from the external perspective when we define the interfaces for these parts that we haven't made yet. So what you end up with when you work with test doubles in an outside-in kind of way is you end up with unit tests not for individual classes or methods necessarily, but for unit tests for implementations of interfaces behind which may sit a cluster of classes, a small design. Think of it as being a bit like a microservice. There's a few things in there. It's not huge. It's small enough that we don't need to worry too much about debugging because our test code is never going to be too many layers removed from the code that it's testing, which is always a danger. So it has the advantage of inside-out test-driven development, but it's outside in the sense that the pieces are guaranteed to fit. And if we pitch it just right, if we're not writing tests for every single method and every single class, but writing tests for these key interfaces in our design, then we tend to find that we end up with test code that is still pretty loosely coupled. It just knows about, for example, the get movie method and only needs to work with that. And there may be a bunch of things going on behind that it doesn't need to know about. So you end up with kind of the best of both worlds. It's outside in, so the pieces of your jigsaw are guaranteed to fit, even though you haven't actually written them yet. It's outside in the sense that your tests tend to be pretty loosely coupled from the test code. But at the same time, they do pinpoint it's in this part of the code. It's in this little cluster of classes here, or this little cluster of functions here. And it has the advantage of being pretty good at pinpointing failures in the sense that it's saying, well, it's here. It's around about here. So those are stubs. Stubs provide test data. There are many reasons we could use a stub. We could use a stub to pretend to be an external dependency. We could use a stub to pretend to be some other cluster of classes that have a responsibility we don't want to think about yet. So we can define the interface that from the outside in. We can also use stubs to provide data that is changing or random to make our tests completely repeatable. So let's say, for example, we're connecting to a service where the data coming back is date-driven. It's changing all the time. We might say, well, okay, we don't want that data to change because at some point these tests might start failing when the clock strikes midnight on one particular day, depending on what test data we chose. So we might choose to hard code that test data using a stub so that, for example, if we're testing the age of people borrowing videos from our library, we don't choose a date of birth. We just have something that calculates ages. We stub that so that the age of that particular member is always the same, no matter how long we run these tests for. So those are stubs. They provide test data. Now, there's another kind of test double we need to think about. Stubs are useful for when we have what are called query methods, methods that provide data, and we need to create stub versions of those. Test doubles of those. But what about commands? What happens when we need to tell an object or an external service to do something? Again, we don't necessarily want to connect to that external dependency, or it may be that dependency doesn't exist yet. We're going to fake it until we make it. So how do we write tests? How do we test driver design for logic that involves telling other objects to do something? Well, for that we can use something called a mock. A mock object allows us to test an interaction between the object we're testing and one of the objects that it tells to do something. So the example we have here in this requirement is that when movies are donated to the library, then we send an email. It's called a new movie email to all members. So that's the requirement. Now, we don't actually want to send emails as part of our unit test, but we are interested in whether or not the library tells some object to do that. So this time we're not going to write an assertion. We're using a mock object, and I'm going to be using a framework called Mock, M-O-Q, which I think is one of the most popular ones for .NET. And first of all, we're going to need to add mock to our package dependencies here. So let's import that. There we go. That will bring a bunch of necessary stuff with it, as you'll see in a second. Let's import mock. There we go. So it'll take it a little while there. It's importing a bunch of things. So we'll... there we go. So there's a bunch of things there, but you don't need to worry too much about them. The important thing is mock. Now, the way that mock works is instead of asserting, we verify on a mock object that a method has been invoked, and optionally it's been invoked with the parameter values that we said it should be invoked with. In other words, was this method called? So we're going to work backwards. Let's imagine we have a mail server. So imagining that for now. And we're going to verify. This is our mock object. We're going to verify on our mail server that one of its, let's just call it M, that one of its methods is invoked. Let's call that method send. And it's invoked with this information. So the name of the email template to use, the distribution list that the email should be sent to, and at the end there's an array of argument values, information we would insert into this template. So that's going to be a string array, and the first one is going to be the title of our movie, and the second one is going to be the year as a string. So this is the mock equivalent of an assertion. Let's start working backwards from here. So this is going to be our mock object, and to create these using mock, what we do is we declare a new mock, and we tell it what type of object it needs to mock, in this case mail server, and let's import that, and let's declare our email server interface there. Okay, there's our mock. Now, what we're doing is, again, we're designing the interface for this object, this email server interface. We're designing it from the client's point of view. We're designing it from the outside. So let's call that template. Distribution list and args. Now, the setup is very, very similar. We have our title. It doesn't actually matter what the title is. It's all pretend data. We need to know what year this was released, 1989. Okay. Now, we need our library. And our library is going to need a source of movie information. We can't leave that blank. So what I'm going to do is use the stub just to populate that. There's our title. There's our year. So we can't leave that blank. We'll talk about what kind of test double this is in a minute. And then we're going to donate to our library just as before. Again, remember the IMDb ID is totally made up. It's all make-believe. So it doesn't really matter what it is, as long as it was of the correct type. Okay, so what we're saying is when we donate a movie, this method, send, should be invoked on our mail server mock object. Now, how is library going to be able to actually call that method? It needs us to pass in the mock object. Now, the way we do this with mock is we have an object property, which is a reference to the actual object, the instance itself that has that email server interface. Let's add that to our interface, to our library there. Where is it? There we go. Just going to quickly rename that. Okay. Now, when I run this test, what's going to happen is that, aha, yes, we won't be able to run the test because it's going to need something passed in here. So I'm just going to use mock to create an instance. Pass in that instance there. So now we should be able to run this test, see what happens. Let's make sure we're running all of our tests. Any second now. Okay, now let's look at why it's failing here. Look at the message. Expected invocation on the mock at least once. So it's expecting that method to be invoked. And if it's not, that test will fail. And that is the reason that mock objects were invented. They were invented to solve the problem of how do I, if I'm doing test-driven development, how do I write a test that fails if a method is not invoked, if a command is not, a message is not sent. Now, to make this pass is very, very straightforward. Let's assign that to a field. And then in our donate method, after we've added our movie to the catalog, then we just need to invoke that method with the right parameter values. So in this case, it's new movie, I believe. And we need to invoke it with the year as a string. So we're going to need a local variable for our movie. That's easily solved. No, maybe not so easily solved. Local variable. Let's make it a movie. Okay. And we need to tell it who to send it to, all members. And then finally, our collection there of information about the movie. So the title and the year as a string. So now when I run this, theoretically, because that method is being invoked, this test should pass. Excellent, right. Now at this point there will be some more refactoring to do, no doubt. These classes really need moving into their own files and probably into their own project, for example. We've got some duplicates set up in the tests here, so we might be able to do something about that, although with only 2 tests I'm not so worried about that. But what we've done here is very similar to what we did with the mock. From the outside, we defined that something needs to happen, and then in order to pass that test, we defined a placeholder for sending emails. So that's what that test was all about. It was all about what should the shape of that placeholder be, looking at it from the outside in, looking at it from the external or the client perspective. The email server, the code to actually send the email doesn't exist yet. We would move on and test drive an implementation of iMail server. So that would have its own unit tests as well. And again, we've separated the concern of how the library works from how do we send emails. How the library works is our problem. How we send emails is somebody else's problem. So we have true separation of concerns, which means we can unit test the logic of our library. And it also means that we can change how we send emails without having to rewrite library, which is a very important thing from a design perspective. So when we drive designs using test doubles from the outside in, it enables us to get some of the benefits of both outside in TDD and some benefits of inside out TDD. So we can have our cake and eat it. It allows us to drive complex multi-layered designs of arbitrary size, provided that we have good separation of concerns by just saying, well, we'll get to that later, or that will be somebody else's problem.